AIM, arithmetic sequences and series. Please take a moment and copy down the notes. I will elaborate on them in a moment. Please pause the video and do so. Arithmetic sequence. A sequence that has the same number added to each term to get to the next term. D is the common difference between terms, and you can find the common difference by taking any term and subtracting the previous term. Or if you prefer, you can take one term and figure out what are you adding to get to the next term in the sequence. Please move on to the next slide. Please take a moment and copy down the note. Afterwards, use the formula for the example. Please pause the video and do so. This formula is for the nth term of an arithmetic sequence. A sub n equals a sub 1 plus the quantity n minus 1 times the difference. Example, find the nth term of the arithmetic sequence if a sub 1 equals -2, d equals 7. The first thing I will do is write down the formula to help me. A sub n equals a sub 1 plus the quantity n minus 1 times the difference. That means I have a sub n equals a sub 1 is -2 plus n minus 1 and the difference of 7. And let's go ahead and simplify this out. You can distribute that 7, and that means I get a sub n equals 7n minus 9. So this would be the nth term of this arithmetic sequence. Please move on to the next slide. After you write down the directions for the example, please find the indicated term of the arithmetic sequence. Please pause the video and do so. Since this is an arithmetic sequence, the first thing I will do is write down the formula, which is a sub n equals a sub 1 plus quantity n minus 1 times d. Since my n is 55, that means I'm looking for the 55th term, so that would be a sub 55 equals the a sub 1 represents the first term and -1 is the first term. So now my n is 55 minus 1, and there's enough information here for me to figure out the difference. The difference is, in this problem, 3. You can think of it as one of two ways, either using the definition of d, which means take one term, for example the 8, subtract the term before the 5, and that will give me the difference 3. 8 minus 5 is 3. Or you could take the 5 and subtract the previous term 2 and get 3. Or if you prefer, you can take any term and think to yourself, what am I adding to get to the next term? Well, plus 3, to the next term plus 3, and so therefore the difference is 3. And now we can finish this problem because I'm looking for the 55th term, so a sub 55 equals -1 plus, in this case, 54 times 3, and a sub 55 equals 161. Please move on to the next slide. Please work out number 2. Please pause the video and do so. Number 2, we are finding the 60th term. So let me first write down the formula. A sub n equals a sub 1 plus quantity n minus 1 times d. Because I'm looking for the 60th term, that means I would be first writing a sub 60 equals a sub 1. Well, the first term is negative 5 square root of 2 plus in parentheses n minus 1. Well, we know the n is 60, since that is the 60th term, minus 1. And now I need the difference d. The difference is 3 square root of 2. Remember, to get that, we can subtract one term minus the previous term. So you can take negative 2, for example, square root of 2 minus term before, which is negative 5 square root of 2. And of course, now this is the d. Let me just write that in there. Negative 2 square root of 2 plus 5 square root of 2. And of course, let me get rid of these since I already wrote the equal sign down here. And that gives me 3 square root of 2. So not too difficult to figure that out. Now let's finish this problem. We have a sub 60 equals negative 5 square root of 2 plus 59 times 3 square root of 2. A sub 60 is negative 5 square root of 2, and now we can multiply these. 59 times 3 square root of 2 is 177 square root of 2. And now when I combine these, I get 172 square root of 2. We do not want to change this to a decimal. We want to leave it as an exact value, as a rational, as a square root. Once again, 172 square root of 2 is an exact value. Please move on to the next slide. Please take a moment, copy down the formula for sum of an infinite arithmetic series. After you do so, please find the sum for example 1. Please pause the video and do so. Sum of a finite arithmetic series is the formula S sub n equals n divided by 2 times the quantity a sub 1 plus a sub n. Please remember n represents the number of terms in the series, and the word finite means we know how many terms are in the series. So now let's go ahead and work out number 1, find the sum. So this is an arithmetic series. First thing I will do is to write a formula down to help me. So now let's go ahead and plug in what we know. So S sub n, I don't know yet how many terms are in this arithmetic series. So what I'm going to do is I'm going to leave this blank. I cannot write n because n represents the number of terms, and I don't quite know how many terms. I'm given the first 3, then we have the dot, 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 and it goes all the way until 71 with that same pattern. And I don't want to sit here and start counting one at a time. So let's not worry about that yet. We may have to worry about that later. And it looks as if we definitely will need to worry about that later, because if you notice, I don't have this n value yet. A sub 1, well, that's the first term, that's 3. A sub n represents the last term, and the last term is 71. Even though I do not know what number of the term that is, I at least know that's the last term. So we have a slight problem. We somehow need to get that n value. How can I get that? Well, let's look back at the formula we used here, because there is the n value right here. So let's use this formula and work it out here. Let me go ahead and write that formula down, which is a sub n equals a sub 1 plus the quantity n minus 1 times d. So let's fill in what we know, and let's hope we're able to get that value of n. So a sub n represents the last term of the series, and we know that is 71. A sub 1 represents the first term. Well, that's 3. Plus, we do not know how many terms, and n represents the number of terms. And that's what we're trying to find. We have minus 1, and now we need the difference. And I think we can see the difference pretty easily is 4. This is good news because I'll be able to get the n value. So let's work that out. 71 equals 3 plus 4n minus 4. 72 equals 4n, and that means n equals 18. This is good news because now I have the n value. So I can now take this n value and put it in these two slots that I did not originally know. So now I know that there are 18 terms, and I can put 18 in both of those positions. And now I can finish this problem. So that means I now am finding the sum of 18 terms. And of course, I have 9 times 74, and the sum of all 18 terms becomes 666. Please move on to the next slide. Please work out number 2. Please pause the video and do so. Since we are finding the sum, I will first write down the formula for sum, which is S sub n equals n divided by 2 times a sub 1 minus a sub n. So now that is S sub n, but I don't quite know how many terms are here. So I'm going to just leave that blank. Equals, once again, I don't know how many terms there are. Divided by 2, a sub 1 is 7, and a sub n, the very last one, is negative 299. Oh, I forgot a little plus sign right there. Make certain you put the plus sign right in there. So 7 plus, oh, let's go back to that color, 7 plus negative 299. So we see what's going to happen there. So I need to find the n value. So let me use the same formula I used last time for the nth term of an arithmetic series, which is a sub n equals a sub 1 plus n minus 1d in parentheses times d. So let's go ahead. A sub n, I know, is the last term of the series, which is negative 299. A sub 1 is 7 plus n I don't know, and that's what I'm finding. And the difference is negative 6. Make certain you put that in parentheses, or else it will look as if you are subtracting. And let's work this out. So negative 299 equals 7 minus 6n plus 6. And let's see, negative 299 equals 13 minus 6n. Negative 6n equals negative 312, and that means n will be 52. So that tells me there are 52 terms in total here. So now let's plug in the value that I know. I know n is 52, so that will go right here. And it will also go right here. And now I can work this out and finish the problem. So now the sum of 52 terms will be 26. 7 plus a negative 299 is negative 292. And the sum of 52 terms will be negative 7,592. Please move on to the next slide. Please take a moment, copy down the example, and work it out. We will go over it in a moment. Please pause the video and do so. Example, find a sub 1, d, and the nth term for an arithmetic sequence when the fourth term is 3 and the 20th term is 35. Since we are not locating the sum here, we do not need to worry about the formula for sum, which means we need to use the formula for the nth term of an arithmetic sequence. So I will first write down that formula, which is a sub n equals a sub 1 plus, in parentheses, n minus 1 times d. I will fill in the values now for when the fourth term is 3. So that means if the fourth term is 3, then that would have to be the 3. I don't know how many terms there are. I do not know what the first term is. I also know that the n value would have to be 4 because there's 4 terms, minus 1 times the letter d. Okay, well, let me now do the same for the other information I'm given, which tells me the 20th term is 35. So let me go ahead and say, and I'll first write down the formula. It's good practice to help memorizing it. So a sub n, well, that's the last term, the last value, I should say, of the term, which is 35, and then a sub 1, I don't know because that's the first term, plus n tells me how many terms, I don't quite know. And my apologies, I do know that. It's the 20th term. I should have written that in there. So we know this is 35 equals a sub 1. I do not know that, plus the n. That tells me how many terms, and that's 20 terms minus 1. The d, though, is what I do not know. There's not enough information there. If you notice, I have two equations with two unknowns. The two unknowns are a sub 1 and d. And as long as I have two equations with two unknowns, I can solve them simultaneously. So that's what I will do. I will solve each of these equations for a sub 1 and then set them equal to each other. So that means I will have 3. I'll start over here. 3 equals a sub 1 plus 3d. And that means a sub 1 equals 3 minus 3d. Let's go over to the other equation. And I will have 35 equals a sub 1 plus 19d. And a sub 1 equals 35 minus 19d. So now what I will do is I will set both of these equations equal to each other and say 3 minus 3d equals 35 minus 19d. As I work this out, I will get 16d equals 32, which tells me d equals 2, so that's one of the values that I'm looking for. I was looking for a d, and now I'm looking for a sub 1. Well, that should not be too difficult to find. So as long as I plug a sub 1 back into one of these, as long as I plug the d back into one of these equations, I'll be able to get that. And if I plug it in here, I think we can see I'll get 3 minus 3 times the 2. Well, that's 3 minus 6, so that would be negative 3. So that one was pretty easy to get. So that means a sub 1, and I can even come over here and we can write that down. So a sub 1 equals 3 minus 3d. And we get negative 3. And lastly, I need the value of a sub n, because that will be the what I'm looking for. And that will be the nth term. So now I need a sub n equals, remember that is negative 3 because that's the first term. And even if it helps, we can write down the formula again so we know what we are writing. Remember, I'm trying to find the nth term, so it will begin with a sub n equals, the first term is negative 3 because I just found that here, plus n. Well, I just found n to be 2. Oops, sorry, I found n, which stays as n because this is the nth term, minus 1, and the d in this case is 2. And now let me simplify everything. And that will give me a sub n equals negative 3. I will distribute 2n minus 2. And a sub n equals 2n minus 5. So once again, the three pieces of information I was looking for the a sub 1, which is here, the value for d, which is here, and the nth term for the arithmetic sequence, which is here. Please move on to the next slide. Please begin the homework. Notice that the homework works itself down to here.